We have our last two questions on this one for now, which is let R be the region bounded by the graph of y equals the square root of x and y equals x divided by 3 as shown in the figure to the left. So this one here. Some things that I know from here, the square root of x and x over 3. X over 3 is a linear equation, so I know the bottom function is going to be x over 3. The top function is going to be the square root of x. The other thing that I know is that this point right here is 0, 0. The other point is 9, 3. The only thing that we care about right now and has been is the x values. So what we need to make sure is that when we read these problems, if it says perpendicular to the x-axis, then I want the x values. If it said perpendicular to the y-axis, I want to look at the y values. So I have perpendicular to the x-axis in both of these. It says the region R is the base of a solid. For the solid, the cross-sections perpendicular to the x-axis are squares. Find the volume. So we have squares again, so we know our area is equal to our side length squared. And our side length is based off of the distance between our two functions. So then I know whatever our side length is squared, that's going to be our area function. So we take the top equation, the square root of x, minus the bottom equation, x over 3, we get our area equation is square root of x minus x over 3 all squared. So our volume equation, we're going to integrate it from x equals 0 to x equals 9 of the square root of x minus x over 3 squared. Then we can go ahead and simplify what we need to. So I would potentially multiply out what I have here, integrate what we have left over, plug in our bounds, all of those things, and what this is going to eventually give us is 27 over 10 or 2.7. Okay, and this last one here, the region R is the base of the solid. For this solid, the cross sections perpendicular to the x-axis are semicircles. So we're semicircles again, so I know our area function is pi r squared divided by 2, and our radius is half of that distance between our two functions. So our two functions, the top minus the bottom, and whatever we get, we're going to divide by 2. So I know I need to divide by 2 and square whatever we have here. And that distance between our two functions is that top equation minus the bottom equation again. So if I know what we have going on here, I can go ahead and plug this in as is. I don't even need to simplify this at all. I can say the volume is equal to the integral from 0 to 9, our bounds, of this whole thing. So pi divided by 2 and our radius divided by 2 squared. So our radius is the square root of x minus x over 3 divided by 2 because it's cut in half, and squared because our radius has to be squared for this. This one is, if I get rid of this, it's the equation from right above, but I also have to get rid of the divided by 2. So I could pull out all of those constants. 2 squared is 4, so I'd be doing divided by 4 and then also dividing by another 2, so dividing by 8. So this ends up being pi over 8 times 27 over 10, or 27 pi over 80. But like I said, how we solve this problem is going to be dependent on what we're given, what kind of problem it is, where it's located on the AP test or the test that I give you. So everything that we do to solve this problem just depends on what type of question it is.